Random. Okay, cool. So let me just open up my Delta Math so I can take a look at that. Exponential equations, common base, exponential. Oh, okay, level 1, 2, or 3. Any? Okay, well, let's start with level 1, and then we'll work our way up to a different level if we want to. All right. So let's see. So the first one that I'm seeing says 32 to the power of x equals 2 to the power of 5. So the trick for these problems is you want the base, which is the big number. You want the number that's written normal sized, the 32 and the 2. You want those to both be the same number. And so it helps to have memorized some. For instance, I've memorized that 32 is actually 2 to the 5th. And so what that means is that where the 32 is right here, I thought I was going to draw that in a different color, and it was not. Where the 32 is right here, I can actually substitute that out for 2 to the 5th. So I'm going to get rid of the 32, and instead of the 32, I'm going to write a 2 to the 5th. Now the 32 already had an exponent on it, it had a letter x, so that still needs to stay there. And on the other side of the equation, it's already a 2, so I'm going to keep that a 2 to the 5th. So again, the goal is to make the numbers that are the normal written size, you want them to be the same number. On the left-hand side, 2 to the 5th to the x, we're going to multiply those together, so I get 2 to the 5x equals 2 to the 5th. And then once you can get that common base, you can cancel out your bases. You can just set your exponents equal to each other, and that will allow you to solve for x. On these types of problems, these common base problems, you don't need to use logs or anything like that. You don't need to use a calculator. We're actually looking for single number answers that are either a whole number or a fraction. Ooh, this next one is really big. I might need to get a calculator for the next one. So the next one that popped up when I hit next problem is 7776 to the negative 4 equals 6 to the 3x plus 1. And so 6 can't be written as any other number to a power because 6 is like 2 times 3. So I just got to leave it as 6. What that means for us, though, that means that 7776 is probably 6 to a power. I just don't know what power it is. So that's where I grab a calculator and check to see what power it is. So let's try 2, 3 is 216, 4 is 1296, 5, it's 6 to the 5th. Okay, and then again, we're going to multiply these together. So again, what I figured out on my calculator, I did 6 to the power of 5, and I discovered that that was 7776. So I could replace that with the 6 to the 5th. So this problem now says 6 to the negative 20, 5 times negative 4 is negative 20, and then 6 to the 3x plus 1. Once you have that common base, you can cancel out the bases, and you can just set the exponents equal to each other. And then you have a basic algebra problem, right? So you don't want to overthink it too much. Negative 7 would be the answer to this one. Sorry. Solving natural logarithm equations, is that something on Delta Math, on a homework, on a quiz? Like what, is there a specific problem? The last section on Delta. Okay, let me do this one last problem for Jim, and then we can look at yours next. 216 to the power of 3x, 1296 to the power of 2x plus 5. So as I was working on that previous problem, I did notice that 6 squared is 36, 6 to the third, because I was just trying a bunch of stuff, is actually 216. So I'm going to take out the 216 and I'm going to replace it with a 6 to the third. And there was already a 3x there. And actually 6 to the fourth is 1296. So I'm going to take out the 1296 and I'm going to replace it with a 6 to the fourth. And that one already had a exponent of 2x plus 5. These are multiplication problems in the exponents. So for that first one, I am going to multiply the 3 and the 3x, and that'll make an exponent of 9x. And when you have like adding or subtracting, you're going to have to distribute. So I'm going to distribute that 4. So 4 times 2x is 8x, and then 4 times 5 is 20. And now that we have both of these are the number 6, I can cancel out the 6's, and I get 9x equals 8x plus 20, and then I would minus the 8x, and I get x equals 20 for that one. So hopefully that's right. I don't know, Jim, if you're doing your delta math right now. I believe x is 20. All right. So Reese, I just clicked on that last section of delta math, and so I'm just going to do the first problem that that came up on that, which for me it is 5 natural log of 2x plus 3 plus 6 equals 16. So now on a problem like this, what you need to do, you need to get the natural log part to be all by itself. So that would be from here all the way to the end of that parentheses. So the parentheses is attaching the whole 2x plus 3 to the natural log. And so the things that I need to get rid of, I need to get rid of the 5 that's being multiplied, and I need to get rid of the 6 that's being added. And when you have a choice, you're always going to get rid of your adding and subtracting first. So I'm going to start by minusing that 6 to the other side. And then next I'm going to move this 5. I don't have to make it an exponent. Since there's only one log, I can just divide by 5 and divide by 5, and I can get rid of it that way. So now I have the natural log of 2x plus 3 equals 2. From here, and always when you have these problems with logs, ln logs or log logs, at some point in time you're going to want to get rid of the log. And we get rid of the log by doing the wheel. And underneath an ln, there's always a little e. So we will never write it in there, but it's always there, even if we don't write it in. And so when we do the wheel, we go e to the power of 2 equals the parentheses. And when you do the wheel, you will no longer have the log, the ln, will not be in the problem anymore. So this is changing it from logarithmic form to exponential form. So no more logs, now we have exponents. Now from here we are solving for x. I'll draw that in a different color. We're trying to get this x by itself. And so we're going to move things away from the x. You will never ever solve for the number e because it is a number. It is always the same number. So don't try to get the e by itself. I have 2 things with my x. I have a 2 that's being multiplied and a 3 that's being added. Just like earlier, I'm always going to start with my adding and subtracting and finish up the problem with my dividing. For me personally, I will take e squared minus 3 all over 2. I don't know if the other teachers want you to write it like that or something different. You could write e squared over 2 minus 3 over 2. You could write 1/2 e squared minus 3 over 2. Lots of different ways you could write this for that final answer. And then I think on and on delta math it says solve for the exact value, so they want this like weird answer. And on our test tomorrow too, I think it's going to be all exact answers. I don't think we're going to ask you for any decimals. So just make sure that you're doing the exact answer. Awesome, you're welcome. Okay, so Avery, you're next. You asked for question 7 on the quiz. Oh yeah, and this is like the ones we were kind of doing earlier. So this is quiz number 7, and it says 16 to the power of 2x equals 4 to the power of 3x plus 8. So again, just like the ones we were doing earlier from Delta Math, the exponential equation's common base, you want to try to write the 16 and the 4 both as the same number. You have two options here. 16 is actually 4 squared, which is probably the easiest of the two options. So you could get rid of the 16 and put a 4 squared there instead. And then the 2x still needs to be there. And this side is already a 4, so I can just leave it. Your other option could have been, you could have changed 4 into 2 squared and 16 into 2 to the 4th. Oops, 2 to the 4th is 16. So that would have been your other option. It really doesn't matter. You'll get the same answer either way. On the left-hand side, I am going to multiply those together. So it's 4 to the 4x equals 4 to the 3x plus 8. At this point in time, since I do have a common base, I have that big number 4 written twice. I can cancel those out. And I can just set the exponents equal to each other. And then we would get x equals 8 for our final answer on that one. Oh shoot. Okay, I think I left my review in the other room. I'm going to go grab it super fast so we can do those review problems. Give me a second. Okay, and then somebody asked for 56 on the review. I might need to look that one up on my computer because I think that's a different review than what I gave my students. But I should have access to it somewhere. Let's see. So I have a review that is, it's only 48. Okay, so if you ask for well, let me check my email. If you ask for number 56 on the review, I might need you to type it in for me because I don't know that I printed out that, review. I should probably stop looking for it and just just answer your questions. Okay, sorry, that's really boring. I'm staring at my computer screen trying to find an email. Okay, Carlo, though, I'm assuming you're my Carlo, then we can do number 36 on the review because I do have my review. Actually, I'm not going to do number 36 because there's not going to be one like that on the test, and I say don't worry about it and just it's okay if you leave it blank. Are you okay with that? I can teach it to you. We definitely did not learn it in class. Okay, cool. Awesome. Justin, I have my 38 problem review. I hope that's the one that you want the problems from. 25 and 32, we can definitely go over. Okay. 25, oops, switch back to the black pen. Okay, 25 says the natural log of 2x plus the natural log of 4 equals the natural log of 3x plus 7. So in this problem, we have like natural logs on both sides of the equal sign. And so actually very common to or very similar to our common base problems, if we can make both sides be just one natural log, we can actually cancel them out. So I'm going to take my left side and I'm going to smush them together into one natural log. And adding turns into multiplying. So I'm going to multiply 2x times 4, and this turns into an 8x. And now that both sides are taking the natural log, I can actually cancel out my natural logs. And I can just make the part that was next to the natural log, I can make those equal. So that is 7/5 for the final answer. So again, that's kind of the same as when we were doing the get a common base and then cancel them out. So you can do the same thing with logs. If you can get the same log on both sides of the equal sign, then you can just cancel them out. Oops, we did number 7 on the quiz. Okay, And then number 32. Oh, and we've been doing quite a few examples today with where 6 was our base. Okay, so on this one, it's in logarithmic form. I'm going to immediately start by changing it to exponential form. So I'm going to do 6 to the power of x equals 216. 6 to the power of x equals 1 over 216. And again, when you do the wheel, the log will go away. So the wheel gets rid of the word log. Oh, I found the other one. Awesome. Oh, it's not going to open because... Shoot. Okay. Sorry. Getting distracted again trying to find this email. Okay. So we've done a couple with 6's, right? 6 squared is 36, 6 to the third. And if you don't have these memorized, like, that's fine. Just type them into your calculator. Like, I know that they both have to be a 6 because this is a 6. So I know that 216 is 6 to a power. I just got to figure out what it is, and it's 6 to the third. So if you have not memorized your different exponents, that's fine. You have a calculator. Trial and error. Keep typing stuff in until you figure out which one it is. Okay, now the bigger problem here is this side is a whole number and this side is a fraction, and we don't want that to happen. So I want them both to be whole numbers, and to make a base move to the other side of a fraction bar, we need to make the exponent negative. So that was one of our rules for exponents. It said if you have a negative exponent, it moves to the other side. Also, if it's negative on the bottom, it can become positive on the top. We're kind of doing the backwards of this first rule. We had a positive on the bottom, and we're rewriting it as a negative on the top. And then at this point in time, we can cross out our 6's, and we discover that x is negative 3. Okay. 32. So we did delta 7. 36 we skipped because we didn't need to do it. Skip 36. 25 and 32, I already did that one. 56, okay. I'm still trying to find that, oh, maybe it's not here. Can we do one where a log equals what? Do you mean like the log of 1? Or... Because... Gosh darn. Okay, I need to just stop looking for that. Do you mean one where the it's like log with a 1 next to it, or like log of 1? Or do you want one that's log equals 1? I'm not sure which way. Or if you have one that you can tell me from like a worksheet or something, we can totally do that. Okay, the person who asked for number 56 on the Chapter 7 review, I'm so sorry. I'm looking everywhere for it, and I cannot find that review, like my version of it. And so if you can type in what number 56 is, that would be very helpful, because I'm looking all through all of my emails and I just don't know where that email went. Yeah. Sorry, I've tried. Like log of x equals 1? Because that you just put like a little 10 down here and you do 10 to the power of 1 equals x. And then that's just 10. So you have to remember that the thing that's on the other side of the equal sign, that turns into your exponent. So when a log is equal to 1, that just means that your exponent is going to be 1. Now log of 1, that is always equal to 0, because the exponent that changes everything equal to, exponent that changes everything to the number 1 is the exponent of 0. So if you have a log and then the number 1 is right next to it, that will always have an answer of 0. Okay. I'm still waiting. Take your time typing that problem in for me. I appreciate it. And then while we wait, I'm going to answer a couple other questions. And then as soon as I see that number 56, I will do that one for you. So we had a question about number 2 on the review. And so this one is in exponential form, and we're going to change it to logarithmic form. And so you can do the wheel for that as well. This time, though, instead of getting rid of the word log, we're going to put in a word log. So if there's not already a word log in the problem, you can put one in there. So this one is log base 3 of 5 equals 2x. Log base 3 of 5 equals 2x. And then we do the change of base formula. The change of base formula says you can take a log of any base and you can make it into a log base 10, so you can actually use your calculator. So this will change into the log of 5 over the log of 3. And then you do need to do one more step because you need to get that letter x by itself. And so we need to get rid of this 2, and we're going to divide by 2. And look, when I divided by 2, that put a 2 on the bottom of a fraction. So what I'm going to do is I'm basically going to put a 2 in the same spot, but on the other side of the equation. So I just need to put a 2 below this fraction bar. And now since those 2's canceled, I have just an x by itself, and so this would be my final answer. And again, I think on tomorrow's test, this is the only answer we're looking for. We're not even going to ask you for the decimal answer. I think it's all about calculator ready form on our test tomorrow. Oh, great. Thank you so much for typing that in. I appreciate it. I apologize for not having access to that paper. I should have printed it out before I left work today. Okay. You invest $5,000 in an account that earns 5.5% interest. How much money will the account have after 5 years? Oh, yeah, it doesn't. If it doesn't say anything, I think that we should just assume that it's annually, since it doesn't actually say. I would say, yeah, just assume that it's annually. So you're going to do A equals P1 plus R over N to the power of N times T. And so it's 5,000, 1 plus 0.055 over 1, and then 1 times 5. And then you can type this in your calculator. I don't have my calculator with me right now, so hopefully you can type it in there. Did you get an answer key with that one? Because I feel like a lot of times when we have those types of problems that we'll get an answer key with them. Or I guess that type of worksheet sometimes comes with an answer key. Oh, I found it. That's frustrating. No, this one is still only 48. Okay, I don't know which one had 56. Okay, so we did 56, we did number 2, we talked about log equals 1, 26 and 27 on the review. Okay, so 26 says e to the power of 2x minus 4 equals 5. This is in exponential form. We're going to change it to logarithmic form. Because it has an e in it, we have to choose the natural log. So e's and natural logs always go together. And if a problem starts with the letter e in it, it will always end with a natural log in it. We can do the wheel on this one. the natural log base e. And now that little base e does not need to be written, but that's where the e goes. So if you're curious about like, oh, why isn't the e in the problem anymore? It's because it's below the natural log. We just don't usually write it down. So it's natural log base e of 5 equals the whole exponent. So ln 5 equals 2x minus 4. And then we're going to get the x by itself. So I'm going to add 4 to the other side. I personally like to add it in front of the natural log so that I'm not tempted to add the 5 and the 4 together, because you are absolutely not allowed to do that. And then we're going to divide by 2. Again, me personally, I would accept this as an answer. I don't know what your teachers want, so if they want you to split it up into 2 separate ones, then you could write it like this. You could write it like this. If you want to get super fancy, you could write it like that. Right? These are all different ways that you could write that final answer for number 26. All right, number 27. Very similar, a little bit easier actually, because the exponent is not as complicated as the previous one was. So this is an exponential form. We're going to change it to logarithmic form, and we have to use a natural log because the natural log has a base e. And it's natural log base e of 36 equals the 2x. Of 36 equals the 2x. And then we divide by the 2 to get the x by itself. Again, this perfectly acceptable answer in my book. You could also, instead of dividing by 2, you could multiply by 1/2 and write it like this. And if you want to get super fancy, we put the 1/2 as an exponent, which actually means we're square rooting the 36, and the best answer is the natural log of 6. This, for my students, is fine. Maybe other teachers as well. This is actually, though, the best answer you could give on that problem. So that was number 27 from the review. We are up to number 18 on the quiz. There will be exponential growth and decay problems on the quiz. I think there might be one graphing problem. Just if you need to graph, make that T-chart, and there's a pattern to it. We can talk about that. Let me catch up on these questions, and then we can definitely talk about that. Okay, so we said next problem that we're doing is number 18 from the quiz. Switch my papers. 2 log of 3x minus log of 9 equals 1. Okay, so on this one, we have 2 logs, and so we need to do everything that we're supposed to do to make them into a single log. So I'm going to start by taking this 2, and I'm going to make it an exponent. Now it becomes an exponent on that entire thing, the 3 and the x, and so that's going to change into the log of 9x squared, because I am going to square both of them. And then at this point in time, I'm ready to smush this, condense it into a single log. Because they are being subtracted, I would expect this to be a fraction. And I'm going to put the 9x squared on top. And since this 9 came after the subtraction sign, I'm going to put that on the bottom. Still equals 1, still has the word log. The 9s, we can cross those out right now too if we want. It's 9 divided by 9 is 1. And at this point in time, I'm ready to do the wheel. So remember that log, if there's no base, is a base 10. 10. And so this is 10 to the power of 1 equals x squared. 10 to the power of 1 equals x squared. And 10 to the power of 1 is just 10. And then we would square root both sides to get rid of the x squared. Now on logs, sometimes you can get negative answers, but most of the time negative answers are bad. So sometimes when we square root something, we'll put a plus or minus sign in front of it. But on this problem, because we don't want to do a negative number right here where the x is, because we're not allowed to have the log of a negative number, we're actually not going to do the plus or minus sign, and we're just going to say that the answer is the square root of 10. And again, we're going to leave it in that format. That's an exact answer. We're not going to change it to a decimal. So that was number 18 on the quiz. 18 on the quiz, log equals 1 we did. 27 on the quiz is next. So that is e to the 3x equals 8. We've done some similar to this, I think, from our review worksheet. So here we have, again, something in exponential form, and so we're going to change it to logarithmic form. We have to use a natural log because of the letter e. And it's natural log base e of 8 equals the 3x. And we can divide by 3. This is actually very similar to one we just did on the review. This is an okay answer. I would give my students full credit on the test. A better answer, instead of dividing by 3, you would multiply by 1/3, which can then become an exponent on the 8, which means we're going to cube root the 8. And the best answer to this problem is the natural log of 2. So that was number 27 on the quiz. Okay, Hayden, I'm just seeing your question. Natural log and e does cancel itself out. That happened quite a bit on the front of the worksheet on problems 15 through 20. You could, like number 15, it says the natural log of e to the 10th. You can just cancel those out and say the answer is 10. If it's not in the right format, you do need to change it. So if we're looking at number 17, it's the natural log of the square root of e. You would need to change that to exponential form before you canceled it out. Same thing on number 18. It's not good that it's a fraction, so we would rewrite it as a whole number, and then we can cancel it out. And so that's how you would do that type of problem. Okay, number 5 on our first quiz. Depreciation. Depreciation, good question. Because I think that there's going to be one like that on tomorrow's test. So this is number 5. So I gave my students a mid-chapter quiz, and so we're going to do a problem off of the mid-chapter quiz. I'll type it on here so that everybody can see it, even if you were not my student. So it says a car depreciates in value 12% every 6 months. If you bought this car today for $55,000, how much would it be worth in 7 years? Question mark. Okay. Car depreciates in value 12% every 6 months. If you bought this car today for $55,000, how much would it be worth in 7 years? And so, first of all, you need to choose which equation you're going to use. We will, just like on the quiz, we will have all of the equations typed on the test. We will have one extra equation that was not on the quiz, which is the equation that you learned when you were doing your delta math. And that is A equals P times 1. And then you could either add or subtract, depending on the problem, R, and then it was T over N. Now, this problem is actually a delta math problem, and we will be using this delta math formula. The way that I know that it's a delta math problem and that we want to use the delta math formula is by this phrase right here, every 6 months. When it says every 6 months, every 10 years, every 4 hours, every 2 minutes, every 5,000 years, that phrase every blah blah blah, that's telling you to use the delta math equation. The delta math equation is where the exponent is being divided by n and the r is not being divided by n, right? Because we had the other one, which is this one, t times n. So this is a different equation and we will not be using that for this problem. All right, so we have a starting value of $55,000. Because it's depreciating means that it's getting smaller, it's decreasing. So we're going to use the subtraction problem for this one. And 12% we'll rewrite as 0.12. And then the thing that gets a little bit tricky with this one is that my t and my n are in different units. So my t is 7 years and my n is 6 months, and that's not okay. These both need to be written as the same units, either both years or both months. So you have some options here. If you want to make them both years, 6 months is half a year, so you could change that to a 0.5 instead. Your other option, you could take the years number and you could times it by 12. And so if you wanted to instead, you could use 84 divided by 6, and that would also work. So whichever of those two that you would prefer, you'll get the same answer either way. I always like to, right now, I like to get the parentheses down to a single number, and I like to get my exponent down to a single number before I try to type in to get a final answer. So I have 55,000, this is 0.88, and this is 14. And now this whole thing can be typed into your calculator. On your test, we will not tell you where to round for the money problems because we assume that you know that money always has 2 numbers after the decimal point. So it's not going to tell you to do that, but that is what we want you to do. We want you to round to 2 numbers after the decimal point. All right, that was number 5. Fantastic. Exponential growth. So we talked about that a little bit. I mean, we can do one really quickly. I think the exponential growth and decay is going to be more like questions 3 through 5 on the quiz. I don't know that we're going to actually ask you to graph something. We might ask you to analyze a graph. So you need to know, like, that's growth and that's decay. And if we're looking at a graph for a y-intercept, right, you're just looking for, like, where is this point? That's a y-intercept. Where is, oh, that was a horrible one because that's not realistic, but where is this point? And I always tell my students, yeah, your y-intercept has to be written as 0, comma, a number. It needs to be written as an ordered pair since it is a dot on the graph. Okay. 10 on the review is next in our list. All right. 10 on the review is so easy because it's in logarithmic form, and all it wants you to do is change it to exponential form. Like, that's what the directions say, right? Right in exponential form. So that means they literally just want you to do the wheel, and then that's it. Like, there's no solving. There's not even any variables in this problem that we can't even solve for x. There's no x. So underneath every ln, there is a little invisible e. This e for this fraction, that is not the little e under the ln. There's another one down there, and it will never be written in. So you always have to write in that little e. And so we do the wheel, we do the little e that I hand wrote in to the power of -1 equals that fraction, and that is literally all that they want you to do. They just want you to change it to exponential form. And so this is my final answer. Oh, Carlo, you keep asking the ones you don't need to know how to do number 22 for the same reason that you don't need to know how to do number 36. So we are going to skip number 22 on the review as well. If you desperately want to know how to do that problem, I can teach it to you, but I can guarantee you also that that will not be on the test. Number 22 on the review. Money problems, 3 or 4 word problems on tomorrow's test. And again, we will type out all of the equations on the test for you so that you don't have to memorize them. You do need to know which equation to use for which problem because that we will not tell you. We're just going to type all the equations at the top of that section. So you've got to choose like which equation to use when. All right, 29 on the quiz. quiz is this paper over here? All right. E to the power of x over 9 minus 8 equals 6. So now this one is not currently in exponential form. There's this extra number on the side of the equation where the e is. It's that minus 8. So before I do the wheel, before I put this in log form, I am going to move the 8 to the other side so that the e to the power is by itself. And now that that's by itself, now I can change this into logarithmic form. Just like the other ones we've done tonight where we have a letter E, we're going to write an ln. And you know what? If it helps you, put the little e underneath it. That's where this e went. This e became that little invisible e underneath the ln. And then we do the natural log base e of 14 equals the x over 9. Natural log base e of 14 equals x over 9. And again, we really just want you to get everything into calculator ready form. So you're not, you just want to get the x by itself. We're not doing any decimals, nothing like that on tomorrow's test. It's all just get the x by itself. So the last thing I need to do, I need to multiply by the 9 and get it on the other side. Now, just like with the adding and subtracting, I do suggest that you write your multiplying in front of your natural log, because I don't want you to be tempted to multiply the 9 and the 14 together. You are not allowed to do that. Then it's the 9 times this whole thing. And then you can write this as an answer. If you really super, I would not, but if you really super want to, you could make the 9 an exponent on the 14, and I'm not even going to try to figure out what 14 to the 9th power is. That number will be ginormous, so I would not go past that if I were you. All right, next one is number 31 on the quiz. This one, I can guarantee you 100% for sure there will be a problem like number 31 on tomorrow's test. So really important that you know how to do a problem like number 31. I hope we all have the quiz, so I'm not going to type out the question. It's actually a follow-up to question number 30, and so we're going to use the same formula we used in question 30, and that is the a equals p times 1 plus r over n to the power of n times t. I chose that formula for number 30 because it said the word annual in it. And when it says a vocabulary word that tells you what n equals, that's when you use this formula where the r is being divided by n. And so that's how I chose this formula. Now, number 31 is a little bit different because number 31 actually tells you what a is. It tells you that a is 20,000. And then P is the same 5,000 from question 30. 1 plus my interest rate is 0.045. I already explained that my letter N is 1 because annually means once a year. And then in this problem, I am solving for T. I don't know what T is. Now, I'm not going to write down the letter T because that looks like a plus sign and it might get confusing. So I'm going to change it to an X, but I am solving for time. I'm solving for this T. The next thing we're going to do, we're going to make this parentheses into a single number. And I am 1 times x is just x, so I can just write that as x. Now, one of the most important things that you do not do on this problem is you do not multiply the 5,000 and the 1.045. Since the 1.045 has an exponent on it, you are not allowed to multiply those together. And instead, what we're going to do is we're going to move the 5,000 to the other side. It is currently being attached by multiplication, and so to move it to the other side, I'm going to do division. And now I have something that it's in exponential form. It's a little bit backwards from how we normally write it, so I am going to flip-flop it so it looks a little bit more natural. 1.045 to the power of x equals 4. This is exponential form. From here, I can change it to logarithmic form. This time I'm going to use the log log because I don't have a letter E in this problem. And it's log base 1.045 of 4 equals x. Log base 1.045 of 4 equals x. We're going to rewrite this using our change of base formula so we can actually type it into a calculator. And we get this, and that is equal to x, which means we are done with this problem. You just need to type that into a calculator, and then you'll have your final answer. I think it was like 3.1, or no, I'm sorry, not 3.1. Hold up, let's see, where's that? 31, decimal points are important, 0.459, maybe something like that, years. On the test, I think we just want you to round to one number after the decimal point, so that would be like 31.5 for this problem. And that's how you do this type of problem. And again, I can guarantee you there will be a word problem like this one on tomorrow's test. So make sure that you're using logs to solve that problem. All right, I think I answered all of your questions. If I accidentally skipped one of the questions, can you please retype it in? I did not mean to. I was really trying to go, one line at a time and make sure that I answered all the questions, but I don't know. And then if you have new questions, we've got about 10 more minutes for you to ask me a new question. Yeah, sure thing. All right, so this one is currently in exponential form. I cannot write this as a common base because 20 is 4 times 5. It's not like 5 to a power. So I'm going to change it to logarithmic form. Log, we start here, base 20 of 5 equals negative x. Log base 20 of 5 equals negative x. I'm going to do a little change of base. Log of 5 over log of 20 equals negative x. Now again, on tomorrow's test, we want only the calculator ready format. There, I don't believe, will be any decimal answers, with the exception of the word problems, like those need decimals. But for a problem like this, you really just, your ultimate goal is to get the x by itself. And so we need to take the subtraction sign the negative sign being multiplied by the x, and we need to move it to the other side. You can either divide by -1 or multiply by -1. Either way, basically, you need a negative sign on the other side somewhere. If you're used to dividing and putting it on the bottom, that's fine. You can put it on the bottom. You could put it on the top because it's just a negative symbol. It doesn't really matter where it goes. You could even, if you want to, put it in front of the whole fraction. Just make sure that it doesn't like accidentally connect itself to the fraction bar. So make sure that we can see it. And so any of these 3 answers would be appropriate for a calculator ready version. No, the quiz is not technically the test with different numbers. We do try to stay pretty loyal to, if it's not on the quiz and it's not on the test review, we probably won't put it on the test, just because we want you to be able to have those papers to study when you're getting ready for your test. But I think tomorrow's test is going to be different than what this quiz looks like. It will be somewhat the same, but it's not going to be just a carbon copy of the quiz. All right, number 25 from the quiz, I believe, is next. Oh, we said you could skip 36 on the test review, hun. That I did not teach you how to do that type of problem, and it will not be on the test. (22) and 36 on the test review. You do not need to know. Okay, number 25 from the quiz. I have 2 logs. I need to smush those into 1 log. When they're being subtracted, it's definitely going to be a division problem, a small division problem, not a log divided by a log. A log of a small fraction. I'm going to put the x on top, and the 5 that came after the subtraction sign goes on the bottom. Now that I have this down to a single log, I'm ready to do the wheel. So I'm going to put my little e underneath my natural log to help me out. And that's e to the power of -1 equals the fraction. Now, we're not supposed to have negative exponents in an answer ever, so I am going to take my e to the -1 and I'm going to rewrite it. Negative exponents turn into fractions, so I'm going to make it 1 over e to the +1 if you want to, but you don't have to because you don't need to write down an exponent if it's a number 1. And then finally, again, I need to get the letter x by itself, and so I need to get rid of that dividing by 5. And to get rid of a dividing by 5, you multiply by 5. I am multiplying by the whole number 5. That's a 5 over 1. That way these will cancel. And on the other side, I am going to multiply 5 times 1 and 1 times e. And so my final answer is 5 over e. My x is by itself. This would be done. All right, 28 through 30. Yeah, we can do those. Oops, through 30. So these are on the test review, 28 through 30. And these are all change of base. Sometimes these you can get away with like not even showing any work and just writing an answer. Because they're change of base, you are not going to be using logs for these problems. These are all about like, can I write it as the same number on both sides? And so in this question, I'm going to try to write both sides as a 5. That side's already a 5. And then like 5 squared is 25, and 5 to the third is 125. So 125 can turn into a 5 to the third. And then we did a problem like this earlier today. We said we don't want this side to be a fraction. We want to, magically make this 5 go up here so it can be a whole number. And the way we do that, fractional problems come from negative exponents. So if I make it a 5 to the -3 instead of a 5 to the +3, then I can write it as a whole number. And that reveals that x is -3. Yeah, we can do number 31 after these. And then that might be right up to the end of our time. Okay, so that was 28. Next is 29. Now these, I cannot write these both as 9 to a power because 9 squared is 81, and that's like way bigger than 27. So I need to find a different number that I can write them both as, not a number that is currently on the screen. And that number is 3, because 3 squared is 9 and 3 to the third is 27. So I'm going to replace the 9 with a 3 squared, and I'm going to keep that exponent of 1 plus x that it originally had. And then I'm going to replace the 27 with a 3 to the third, and I don't have to worry about anything else on that side because the 27 did not have an exponent. If the exponent was an adding or subtracting problem, you are going to have to distribute. So this is 2 plus 2x. And at this point in time that both of my bases are 3, I can now cancel out the bases and I can just make the exponents equal to each other. And so the answer to this one is 1/2. Okay, moving on to number 30. In this one, we can write these both as 10 to a power because 10 squared is 100. So I'm going to get rid of my 100 and replace it with a 10 squared. I'm going to keep the 2x that was there. On this side, it's already a 10. I don't got to do anything because I've already got a 10. These will be multiplied. And then from here, I can cancel out. I have my common base. I can just set my exponents equal to each other. And I'm at my answer now. X is 2. I did number 31 on the quiz. I just did it a couple problems ago. So when we're done with this, go back and rewatch it. It's right at the end of the recording. Oh no, John, I know, hon. Hayden was asking to see a word problem where we have to solve for t. I was just telling him that 31 on the quiz was one of those. We're gonna do number 31 right now. No, don't apologize. It's cool. So we are gonna do 31 on the review. I'm ready for it right now because we just finished number 30. And then I think that's all that we're gonna have time for. So again, Hayden, when we're all done, you can go back and watch the video. And we did number 31 from the quiz, and number 31 from the quiz is solving for t on a word problem. So definitely go back and watch that one. You can also look things up on Delta Math. Let me see if I can figure out what section it is. It's not that one. It might be in, no, because that's all solve for future. What is value? It might be in exponentials, various forms and units. Maybe check in there and see if they have some more examples of solving for t. I feel like we for sure did some on your Delta Math. Okay, sorry, I got distracted again. I'm trying to look up these problems for you guys. Okay, so on this one, it's in log form. We're going to change it into exponential form. So it's 36 to the power of 1/2 equals x. And make sure that you write that as an exponent. It's to the power of 1/2. It's not times 1/2. We're not doing half of 36 is 18. We're actually doing, so fractional exponents, those turn into radicals. So 36 to the 1/2 actually means let's square root, 36. And this word of 36 is 6. And again, we don't want to include the negative version of 6. We only want to include the positive version because we can't take the log of a negative number. So this is just the final answer. Oh yeah, 20. I can do 20 really quick for you, Chuck. 20 is just change of base because it's already, the x is already by itself. So you don't have to you don't have to do the wheel or anything like that because it's kind of already solved for x. It already says x is the log base 2 of 7. So all you have to do is change it. The change of base is where you write it as a log divided by a log. That's the one where it says, you know, a log of any base can be rewritten as a log base 10. You just make this a log, and then you give a log to this one down here. And so that's just the final answer for number 20. And then we said also that I don't think we're going to ask for any decimal answers on tomorrow's test. I think it's all just going to be calculator ready form. So it's really important that you can do this. Oh, I wonder if it's, is it that one? No. Okay. All right, guys. I think that's it for me for tonight. I hope that was helpful. And again, if you joined us late, you can watch the video. It's going to take me maybe 5 minutes to try to get it posted to the website. So you can totally check back in about 5 minutes and watch the video. You can rewatch some problems if you need to. And I wish you all the best of luck on your test tomorrow. You're welcome, hun.